Okay, so I want to talk a little bit about this concept called an interface, and its relation to an even cooler idea, namely polymorphism. This first example, actually, as you can see, it's taken from one of Kai Horstman's other books, Object-Oriented Design and Patterns book. It's actually an excellent book. It's fairly thin, but it is really packed with great information. If you want to kind of further your knowledge of object-oriented design, I highly suggest picking that up. Basically, what we're first showing here is just this very simple use of a class called JOptionPane. Now, JOptionPane lives in the swing package, the JavaX swing package. Right there, it is. And basically, it's a way to very easily make make modal dialogues. Okay, dialogues that pop up and either provide information, get some confirmation, those kinds of things. And so here I have just a really simple example. The simplest way of calling show message dialog, a static method on JOptionPane. And you'll see there's our message. So when I run this, it's real simple. It just pops up this little window here. Whoop. Pops up that little window there. That is in fact a there we go. Okay, that is in fact a modal dialog. Okay, and then basically the program is done. Once again, so there I can show that. See, there's the message, hello world, and I click OK, and basically we are essentially done with the program. Okay, now the main point about JOptionPane was that the designers of Java wanted to make it useful. And by useful, essentially the idea is they wanted it to be highly customizable. They wanted they were building this component for other programmers to build their programs on top of. So, for example, if I go back over to here, and I search for, notice, it gives us this little, this little diagram of roughly what the box or what the dialog looks like. And it has this thing called an icon, right? So the icon, you'll notice again, I'll just point it out here. In this particular example, it's that right there. It's that little eye in the circle. It's sort of an generic information icon, okay? And Java actually has some additional ones built in, etc., that you can use for sort of alerts and all of those kinds of things. But what if it's the case that you wanted your own icon? What if you wanted your own kind of drawing and so forth, right? So it says icon. The icon is wrapped in a JLabel displayed in the dialog. Okay, then it says a little bit about message types, and those actually, each of the different message types have different default icons and so forth, and go on and so on and so forth. So what exactly is an icon in Java? Well, here's what it is, right? So if I go to icon, you'll notice it says interface icon, right? Let me actually pull this up here. So here's the Java documentation for JavaX Swing. And if you've been looking at the Javadoc documentation, you probably have seen this in packages. The first thing that it shows in packages is the interface summary. Okay, these are not classes. These are interfaces. Okay, interfaces generally are pure abstractions. That is, that they basically don't provide any functionality in and of themselves. Now, up until Java 8, that was 100% true. With Java 8, they had to do a little bit of stuff to kind of shoehorn in some of the new features. So sometimes it's the case that interfaces can have a quote-unquote default implementation. We'll see that later. But for right now, basically, it is a pure abstraction, right? The whole idea is that what they've essentially defined right here, what the developers of Java have defined right here, are exactly what functionality and the names of that functionality, as well as the signature, for something to be an icon. Okay, so for the J option pane to be able to show an icon, it has to know what the height is, right? And the way that it can find out that, it calls a method called getIconHeight that returns an integer. Similarly, we have one for width, and finally there's a paintIcon method for, notice, drawing the icon at the specified location. Okay, again, this is an interface. There is no particular implementation. There is no implementation for an icon directly. Okay, the whole point is that this provides a compiler enforced manner to come up with a specification, a formal specification, right? So the developer of J option pane, rather than just saying to everyone else, hey, you know what, you need to have a way of giving me the icon's height, the icon's width, and painting the icon, right? Then everybody goes off, they do their own thing, right? So somebody maybe calls their, instead of calling it getIconHeight, they call it getHeight and getWidth, right, and paint. Or maybe they screw up the order of the parameters, etc., right? In those kinds of cases, if you don't have an interface, then when you try to get your code to work with the other person's code, it doesn't work. Right? It doesn't work because, well, people didn't quite follow directions. So instead, having the notion of an interface means that what you can do is you have a formal specification that the compiler will enforce, right? So if you're writing something that implements an interface and you name it something other than getIconHeight, your code's not going to compile. Because you have to have a method called getIconHeight that doesn't take any parameters and returns an int. Similarly for getIconWidth, similarly for paintIcon, and so forth. There are plenty of examples in the real world of this, right? Take a look at your nearest electrical socket on a wall, right? Think about this. Okay, who actually provides the electricity for that? We're in Tampa. Most likely, it's probably TECO. There are a couple of other ones, right? But think about it. What is behind that? So Tampa Electric is the one that actually provides the power. Who builds devices that consume power? Is it only Tampa Electric? Can I only buy a television set from Tampa Electric? Can I only buy a computer from Tampa Electric? Can I only buy a refrigerator from Tampa Electric? No, thank God. Right? Instead, because there is a well-defined interface, that is, the plug is going to, for instance, look a certain way. The plug looks the way it does pretty much across the United States. Of course, we go to different countries. There are going to be plugs that look a little different, right? And then there's other standards as well that are inherent in that. So, for instance, in the United States, generally we expect that those plugs are going to carry 120 volts. It's going to be on a 60 hertz alternating current, right? So those are the things that we expect. And as long as everybody sort of plays to that, that is, any power provider basically provides that for those plugs, and any electrical device expects that, then we can have basically anyone manufacturing devices that work with that particular interface. The same thing is happening here in terms of code. Okay, so before we go through sort of defining our own interface and all of those kinds of things, really I just kind of want to look at a particular interface and kind of how it might be used. Okay, now, first off the bat, after we've sort of already understood this icon interface, what we should note is it turns out actually there's already built into Java a class in the Swing package called ImageIcon. That, as the name suggests, allows you to have an image that serves as an icon. Okay? And we can even see here in the documentation, right, it says, see also ImageIcon, right? It says also all known implementing classes of icons. So there's ImageIcon, and then there's all these other various kinds of icons as well. Okay, so a class implements an interface. All right, now let me take a look at some UML for this. Okay, so here we have a UML class diagram for, first of all, the icon interface, right? There it is there. Let me actually Actually, typically, interfaces don't have data, so you'll typically see more a box like this. Also note, sometimes you'll see this this particular notation used for an interface. It's also referred to as the lollipop notation. I tend to actually like this one using that makes use of the stereotype here. That's what those little angle brackets there are. Okay, so it says, all right, an icon needs to have 3 methods, right? A paint icon, a get icon width, and a get icon height. The plus in front of there, remember, is public, and the reason that they are in italics is because they are abstract. They are not. There is no implementation for these in the icon interface. Then we have a class, ImageIcon, and our ImageIcon class acts as, that's what this line is, right? So it's a dashed line with a closed arrowhead. That is the acts as relationship. Okay. More formally, it's referred to as realization. Okay, but generally when we read it, we say acts as. Okay, so ImageIcon acts as an icon. Now, realistically, if you actually look at the documentation and in the implementation for ImageIcon, there's a whole lot more methods and so forth, and there's actually a bunch of data members and all that. I've kind of taken those out because we don't really care about those for our purposes. But here's the thing that's important. As soon as we say that ImageIcon acts as an icon, what that means is we absolutely must have these methods implemented there. That is, we have to have paint icon, get icon width, and get icon height. And sure enough, there they are. There's paint icon, get icon width, and get icon height. They're already built in because ImageIcon is built in to Java for us. Okay, so let's see how to make use of this. So I'll come over here, and I'm just going to copy this, and I'll paste that in, and we're going to comment that one out. Okay. Now, to make this work, I'm actually going to have to use a slightly different version. I'm going to have to use one of the overloaded versions of show message dialog. Right, so basically to do this, so we'll do a couple of things. So now instead, my message is just going to say that this is ImageIcon Demo. Okay. Then after that, I can basically have kind of a, well, so there's a couple of things. All right, so we can have this. Then we can have, I believe this is the title itself that's going to appear, ImageIcon Demo, and then I'm going to have, right, yeah, there's the title. Okay, then I can kind of have basically some info. I can define sort of what kind of thing I'm dealing with here, namely. So you'll see. So we'll do something like this. We'll say J option pane information message. Okay, and then finally I can specify an image icon. So I'll say new image icon. And then I can simply provide the file name. So when I set up this project, I happen to create an image folder here, and I have one image right there named java_duke.png. Okay, so let's just do this image and java_duke.png. Right, and that is basically it. So let's see what we get by running this. Files indented. Okay. So I go ahead and run this, and there it is. Right? You'll notice that that we have our big honking icon here because the image itself is fairly large. Right? There's the image icon message part. Of course, here's the title, ImageIcon Demo, and since we said yes, we're just dealing with an information message, right? So we just have our OK. So we can click OK, and then basically the program ends, right? So the point being, again, if we take a look at this show message dialog method here, here's J option pane, and we scroll down, let's see, show, what was it again? Message dialog. you'll see there's a number of it is highly overloaded, right? So we can specify the parent component followed by the object message, the parent component, the object message, the title, the type, right there it is, and then finally to be able to specify the icon itself, we're going to need to minimally use this one. Of course, then there's this other one, show option dialog, that kind of goes further beyond the icon and so forth, right? So here's essentially what we've used. So it says we have to pass along an icon, and we've passed along an image icon. Why are we allowed to do that? Well, we're allowed to do that because of the fact that ImageIcon acts as an icon. That is, when we say it acts as that, it realizes the interface, or as we'll see in Java terms, it implements the interface. So that means anywhere we say that we want an icon or expect an icon, we can provide an image icon, right, as one of the options. So that's pretty cool. That easily allows us to load in some particular image. What if we want to do the drawing ourselves, right? So for instance, one of the sort of issues here, let's see, I can't actually make this bigger and so forth. So one of the issues here is clearly, since I have this particular image, depending on my screen resolution, this may start to look weird based on essentially how high resolution my screen is. If I have a really high resolution screen, this might kind of shrink down. If I have a lower resolution screen, this might start to get too big. So we might want to do something that where we do the drawing ourselves. Okay, so let's look at that. We have in this same directory the Mars icon class. Okay, now again, this actually comes directly from Kai's work, so I'm not going to actually write it myself, but I am showing you what the implementation says. Right. So you'll notice Mars icon implements the icon interface. There it is, right? Let's get this actually onto the diagram. So in Umlet, we can do the following. So I could say, okay, generate from there, and then let's see. I'm going to navigate to where I have this, which is there's my documents. Then I got to go. Yep. And Mars icon, right? So that's the particular one I want in here. And notice there it is. It actually has generated that. It has this nasty habit of adding sort of that additional line at the bottom there, which is kind of a pain. But anyways, so there it is. It doesn't unfortunately actually draw in the line, but that's okay. We can add that ourselves. So again, I'm just going to kind of come into here and add that to the same spot there, and then I'm going to move this in over here, like so. Right, and there it is. Okay, so our Mars icon also acts as an icon, right? Notice that means it's going to have implemented these particular methods. Now here's what I want to show you actually. Let me just kind of comment this stuff out. Right now we have these already implemented, but let me show you what this really looks like when you do this. Okay. So here, it's not an icon, right? Yes, it has icon in the name, but that doesn't make it an icon. Furthermore, even if I did this, right? So even if I have the implementation, I have methods with all the same names. The overrides aren't relevant there, and that's why we're getting the error there. But that doesn't make it an icon either. The thing that makes it an icon is when we say that we are implementing that interface. Now, you'll notice that immediately IntelliJ tells us there's a problem, right? What's the problem? Well, let's take a look. It basically is complaining about the fact that it says Mars icon must be either declared abstract or implement abstract method get icon height. In fact, there are actually multiple methods that we're missing. So if we were doing this by hand, we would simply say, oh, okay, go ahead and implement the interface, and then I can do something like that. And you'll notice it actually puts in empty implementations for each of those, like so. It also happens to use the nice override syntax, and that's basically the whole reason for override syntax, right? Again, from dealing with your inheritance lesson, right? Notice when I do this, immediately it says, hey, wait a minute, this isn't working because you haven't actually, I'm getting a complaint here because I said that I'm going to implement this interface, but I haven't actually overridden the method, right? So generally what we do is we will oftentimes put in an override also to tell Java, hey, we are trying to do an override here. And then we can actually kind of come back in like so. This tends to be more helpful. The use of override itself generally tends to be more helpful when you're doing strict inheritance and you want to actually be doing an override, right? With an implements, if I'm missing a method from that, we automatically get the error. On the other hand, if I am extending a class and I'm trying to do an override, well, in that case, I might if I misspell it, then it's actually not going to, then it's not going to be an override. And without having the override keyword here, Java has no idea that I'm trying to do an override. Okay, so that's all that's going on there. All right. So again, now once we have those, you can see basically that's that, and I'm just going to delete these here, and then I'm going to kind of come down, reinstate those, and we'll talk about the implementation. Okay, so our Mars icon, when it gets created, we're going to specify a particular size, right? So we pass in the size, we store that in underscore size, and then very simply, finding out the width and height of the icon is simply going to return that size. Because our icon is simply going to be a circle. Right here, the idea is you're drawing the planet Mars, a red circle. Okay, so how do we do this? It's pretty simple. Okay, all the drawing happens in Paint Icon, right? And then we have a number of things here. So here's kind of what's going on. The graphics class, which actually comes from the Java AWT package, was originally used for drawing on older components. But it turns out that something like JOption pane is in fact a swing component, and therefore we can use the new and improved graphics 2D graphics 2D class, okay? And so the point is that when Paint Icon is called, the graphics that gets passed in is actually a graphics 2D object. On the other hand, if I was using this with a non-swing component, this typecast here would fail, and we wouldn't basically, our program would not draw the icon. Okay, that's all that's going on there. So we could typecast it into a graphics 2D object. Then we do some nice things like turn on anti-aliasing, right? Basically, just get rid of those little jaggies. Then we create an ellipse object, right? So now take a look at this. Looks a little weird. Basically, the ellipse 2D class, there are two classes nested inside. One the double class and one the float class for double or single precision floating point precision. Okay, so we're just using the double precision one. And so we create an instance of that. We specify whatever that X is that of where we're supposed to draw it, that just gets passed in there. Whatever the Y is, we pass it in there. Then for the width of the ellipse, well, it's just our size instance variable. The height is just our size instance variable. Okay, set on the graphics that our color is red, and then call G2, the graphics, the fill method with our ellipse. And that's how you draw a circle. Okay, so once I have that, let me go back over here. Okay, so I'll have something like Mars Icon Demo, and now instead of using ImageIcon, we'll use a Mars icon. Right, and then we can kind of play around with the size. So I don't know, maybe let's try 50, see what that looks like initially. And let me go ahead and run this. And there it is, right? So there's our nice red custom drawn image, or I'm sorry, icon for our dialogue, right? And again, you know, you can play around with this. So we could say maybe 25. Let's see what that's going to look like. Yeah, nice and small. Or maybe we want it bigger, like so. Okay. So that's the basics, or at least the first basic introduction to interfaces. That is, there is an interface, the icon interface, that's built into Java, and the whole point is that it provides an extension point. That is, it provides a way for programmers like you and I to get custom icon behavior by simply writing a little bit of code. Okay? And that's the point of that.